Hello everyone. It's May 28th. Just finished working. Today is work all the way to 1:30 in the AM. It's unbelievable, this type of thing. Alright. Oh, new problem. I haven't even eaten my dinner yet. Things are going really bad. Alright, I think what I'm gonna do is I will definitely take a look at the problem, and if I cannot find a solution in 5 minutes, I'm gonna give it up. I mean, come on, I don't have time for this. I need to eat. I still have to wash dishes and probably clean the floor. I'm not even sure if I can go to bed at 2 and I have to wake up at 6. Damn, this is just tough life. Max number of target nodes after connecting trees. Max number of target nodes. 2 undirected trees. NM nodes. With distinct labels in ranges, okay? Edges 1, edges 2. Edge between the first tree, edge between the second tree, also give integer k. Node U is target to node V. Node U is target to node V if the number of edges on the path from U to V is less than or equal to k. A node is always target to itself. A node U is target to node V if the number of edges on the path from U to V is less than or equal to 2. Return an array of n integers answer where answer 1, I, is the maximum possible number of nodes target to node I. Maximum number of nodes target to node I is target to node V if the number from U to V, so target to I is something to I, right? Something to I, which means all the patterns that can come to I, different path ending at I. Return an array of n integers. The answer is I is the maximum possible number of nodes target to node I of the first tree. Target to node I of the first tree. If you have to connect one node from the first tree to another node in the second tree. Note that the queries are independent from each other. That is, for every query you'll remove the added edge. So we'll add an edge, and then we will see what's the maximum possible number of nodes target to I. If the number of edges okay, so for node 0, k is 2, right? Okay, k is 2. So for node 0, connect node 0 from the first tree to node 0 of the second tree. So first tree is, so we connect this, and we need to find how many nodes can reach 0 within 2, which is the same as how many from 0 going out, right? Because there is no root. So within itself, I already have 1, 2, 3, 4. Yeah, I have 1, 2, 3, 4 within the first tree. And then I want to connect to this. Once I connect, I have 5, right? 6, 7, 8, 9 by itself. So that's 9. So essentially, for within the tree, you're looking for maximum path 2, but for this is a maximum path 1, right? Maximum path 1, including itself. So max path 1 in this case. Here is just 1, 2, 3, but here is 1, 2, 3, 4. Here is 1, 2, 3, 4. Yeah, I can connect to 4 as well. That will also work. All right, so now to 1. 1, I only have path 2. I only have 2. But here is the same, right? It's always the same. It's just to find 1. So that is 4. 1, 2, 3, 4. Right, here we have 4. Here I have 3. 1, 2, 3. So that's 7. Right, I note this I have 1, 2, 3, 4. 1, 2, 3, 4, 5. So that's a 9. And 3, that's a 1, 2, 1, 2, 3, 4. 4 plus 4 is 8. And this is 1, 2, 3, 4 is 8. Okay, so basically what we want is to find on the second tree the maximum you can get when k is equal to 1, right? When k is equal to 1, or when k is equal to k minus 1. How do we do that? Can we just traverse? Like, if I'm at my point, right, I want to see what's the maximum. So I go through my children, and from each child, I need to say, excluding from me, what is the maximum you can get with k minus 1? Right? And when we get it, let's say here k minus 1, I have this much, this much, this much. You add them together, right? So let's say k equals to 2. I have 0, 1, 2, 3, and 4. So k is equal to 2. So if I start from 0, I need to see here, give me k equal to 1. Right? Give me k equal to 1. Okay, now I need to solve k equal to 1 for this. So what I do, I go to its neighbor, and we want to find k equal to 0. Right? K equal to 0. Well, I mean, this one, I don't have any. So if I don't have any, I always have it by itself. Alright, so this one return 1. So this one return 1. This k equal to 1, so I come here. So give me k equal to 0. Give me k equal to 0. Since k equal to 0, you can only return by itself. So you return 1 and 1. So this will return 3. Oh, this will be 4. Right? So 0 start or equal to 4. But this doesn't solve the problem of what's the maximum. Right? What's the maximum? Because you traverse it once, that doesn't necessarily mean that you get a maximum. For example, 2, the answer should also be 4, but we don't know that unless we start from 2, right? And you can say how do a topological sort. We'll pick the node with the highest in degree, out degree, with the highest out degree. Because if you have a highest out degree, it's a little bit greedy here, right? To have a highest out degree, that means you're more likely to obtain the highest count given k. Right? Given k. Okay, so given k in this case, this out degrees. This has 4 out degrees. These all have 1 out degree, so this is the maximum. So as a maximum, we have k equal to 1. Okay, k equal to 1, so we have maximum is 0. Oh, hold on. I need to know at each position. I think we'll have to traverse every single time. Traverse every time to get what this number is. So 0, 1, 2, 3, 4. So 0, what we get is 4. 1, 2, 3, 4, 5. Right, 1. Right, I come here, so 1 is 2, 2, 2, 2. Alright. So now we add an edge, so it'd be 0. Right? So it'll be 0. So everybody is 0. Is it a 1? Now we find out it's 1, so it becomes 6, 3, 3, 3, 3. So, okay. I think it's possible to do this. Yeah, if I can help it. Alright, so we have to do a traversal, we call it DFS, to find the number of target nodes, right? So find the number of target nodes. Get num target nodes. We need a graph and we need a node. Okay, we also need k. Right, k is 0 or 10, 1. Otherwise, we'll do for children, rest equal to 1 for child of graph node. Rest of plus equal to get number target node child k minus 1 and graph. And return rest. Okay. then find each node in graph 1 max target node in graph 2 given k minus 1. The answer is the sum of the two target node count, each node in graph 1. Something like that. So int max max graph 2 I need to have, sorry, I have to do this unfortunately. Let's do this. Get graph. Oh, hold a second. Just need to do that. Okay, then what we can do here is auto graph 1 get graph edges 1. What is n and what is m? Oh, you don't tell me. You don't tell me. Oh, but the length tells me. Length plus 1. Okay, then that's that. And I have max graph 2. Target node count graph 2. I0 is smaller than I just okay, int Right, edges 2, edges 1. We can say max count 2. Ooh, I have to prevent back. Oh. Visited. We have to do visited. Well, it's a tree, right? So you only need to make sure it doesn't go back to the parent. So don't need that. I just need node parent if child not equal to parent. Node. Okay, so here I parent that's k minus 1. This is what we want to find. And graph 2. Okay. And then vector int res n 0 as small n I plus plus res I shall equal to get num target node I minus 1 k graph 1 okay plus what? Plus max count 2. Okay, let's see. Alright, if it doesn't work, then we'll just check the answer and then deal with it tomorrow. We'll submit, let's see if it works. Oh yeah, it does not work. Oh, if n is smaller than 0, return 0. This actually might work. We passed 700. Yep, we passed all of them. Yeah, one of the better ones. A little bit surprised that one shot at such a late time. Usually my brain is quite fried by here. Especially today, was dealing with a lot of, design issues. I'm surprised. Yep, that looks good. Okay, that's it.